Good afternoon everybody. Welcome to this roundtable organized by CAREL and Recuperator. My name is Simone Grisenti. I'm a Group Marketing Manager, HVAC Commercial for CAREL. Unfortunately, we're not able to meet in person this year because of the emergency for COVID-19, but thanks to technology, we are able to be in touch virtually during this interesting roundtable. Just a couple of words while we are waiting for all the people to connect. The topic of today is very interesting. We are going to talk about air handling unit and how to manage ventilation units in order to put together hygienic aspects, efficiency, and comfort as well. Together with me, there are two important guests. The first is Andrea Pagan, Application Manager of CAREL. Andrea has a very strong experience in ventilation. He's working on a daily basis with the most important manufacturer and with many important designers. So he will bring his important point of view into the discussion. And then there is Paolo Liberati, R&D Manager of Recuperator. As you know, Recuperator is now part of CAREL Group since a couple of years. So let's say we are all colleagues here today. And of course, Recuperator, as you know, is one of the leading company in heat exchanger, one of the most important components inside the air handling unit. So Paolo will bring his expertise in the discussion today. So we are here merging all the different competencies and knowledge of CAREL Group together. So before starting, a couple of rules. I don't know how many of you are familiar with the Zoom tool. At the bottom of the screen, you will find the function to post your questions. We will try to answer to all your questions at the end of the presentation. So please type all the things that you consider important to put into the discussion. So I think we can start. We can share the screen with some slides that we can show. As I told you at the beginning, we are going to talk about indoor air quality. Indoor air quality is a basic requirement for life. So having good air is necessary for our well-being and for having a healthy life. A couple of numbers, just to think. We are spending 90% of our time indoor, and we are eating 1 kilogram of food per day, 2 liters of water, but we breathe every day almost 12,000 liters of air. So we can imagine how important it is, the quality of the air we are living in. After the emergency following the spread of COVID-19, we are, let me say, following many rules, many requirements, recommendations, like for instance, opening basic requirements like opening windows, but even managing the ventilation system to renew very frequently the air we are breathing. But even it's necessary to control the condition of the air we are breathing in terms of temperature, in terms of humidity. And at the same time, it's very important to continually monitor and control the system managing the ventilation. So I will start involving immediately Andrea, asking him why air handling units are so important and what are the most important things that we have to keep in mind when managing air handling units.
Okay, thank you Simone. In this particular era that we are living now, air handling units started to rise is that's important, really important for us, because air handling units are one of the most important part of the ventilation system. It ensures the controls over the air parameters that impacting on the human health and well-being. Air handling units control the most important microclimatic factors that are, for example, air temperature and the relative humidity of the air inside the confined space. But another important thing is related to the air cleanliness. When we talk about air cleanliness, we mean that we take under control all the factors that are related to the chemical factors like CO2, VOC, dust, and other pollutants that can be present inside our room, our environments. On the other hand, we have also to take into consideration to use the ventilation system as an important strategy to control also the bacterial contaminants like bacteria and other pathogens like viruses, for example, that are quite important in this period. In the past, when we are talking about the running units, we mainly take into consideration to ensure their comfort for the as a main target, main pillar for designing the operation of R&D units. The introduction of norms and regulation given by the government and the attention of the people for the sustainability of our HVAC system and for all the things that we have in our hands rise the importance of the energy efficiency and the reduction of the energy consumption for the HVAC. But now the COVID-19 and the era that we are living now increase the attention on another important pillar, that is the health. We want to live in health environments, and so health becomes an important pillar for designing and operation of the R&D units. So how can we get these targets? I think that, and it's not what I think, but it's a clear recommendation also from the regulation and norms that start becoming quite common, not only for the OEM manufacturers, but also for the designer. These norms and regulation has a great impact on the right choice of components. So selecting the right component, designing the right components that keep the R&D unit is an important factor for creating an R&D unit healthy and safety. Designing the R&D unit and design control strategies that are able to control properly the R&D unit. And on the other hand, we need also to increase the efficiency and also the safety of the R&D unit through equipping with the remote management system. That can have an important role that in the next slide we can see how can improve the quality of our R&D units. So all these factors can play a fundamental role for making our R&D units safer. We present also VDI norms as an important reference in terms of regulation that we can follow in order to increase the health and safety of our R&D units. On the other hand, the same component, the same factors can improve not only the healthiness of our R&D units, but also can play a fundamental role for making the R&D unit more efficient. Restriction and regulation that are given by the European Commission mention all these topics as important factors for increased efficiency of the HVAC system and the R&D units itself. So CAREL has a wide portfolio of components that can equip the R&D units, and today probably we take a look on the most important one that can give a value to the R&D unit in order to make the R&D unit more healthier and efficient.
Andrea, before jumping into the different components or the R&D unit, you are using a lot of times the word health, safety, VDI certification. So a lot of things usually related to the healthcare or mission critical applications. So I would like to involve the people attending the webinar with the tool, the poll tool of Zoom, raising a question. I will launch the poll. Do you think that the hygiene and health requirements for R&D unit that are generally applied in critical applications such as hospital, etc., will become a standard even in commercial applications or other general applications like offices, school, leisure, etc.? So let's collect the opinion of our guest. A couple of seconds to raise the all the results. I think all the people have now voted. Someone is asking. Rafal is, Rafal, if you want, you can post your question in the question and answer. And if it's a question, if it's something not working with the platform, please let us know still in the chat, and we can address the problem. Okay, so let's end the poll and share the result. The majority of the people is saying yes, so these requirements will become a standard even in other applications. Before better analyzing the results, you are showing a lot of components going around the rendering unit, but I think that the control is somehow the brain putting all these things together. So how important is the role of the controller inside the rendering unit, and what are the most important things that we have to consider when choosing or using a controller?
Yeah, as you said, controller. Yeah, okay.
People are able to see.
Yeah, okay. So control system plays an important role because it interacts with all the devices that keep the rendering units. Apply intelligent logics to all the rendering units in order to achieve the best result in terms of indoor air quality and hygiene is one of the targets that we can get designing in the proper way the control system. On the other hand, it is important also to include some strategies that is able to reduce the energy consumption, because we want to get also the target of energy efficiency for the unit. Control has another important role. Now connectivity has become more and more popular and important for all our activities or in our lives. So through the connectivity of the controller, so we need a controller with connectivity features, we can explore the benefit of using also the capability in remote control, remote monitoring of our system, because getting our unit able to be controlled by remote or to be monitored by remote can increase the value, can increase the performance of the R&D unit itself. So now we can take a look on some control strategies that has to be included in our control system, that has to be designed. And the target of the control strategy was, first of all, to ensure the right quantity and quality of the air that we want to introduce in our building, because we know that increase the ventilation in our confined space can dilute the contaminants and the viruses and all the pollutants that can be present inside the space. The other second topic, main topic for control strategy is to prevent the on-set contamination, because a rendering unit itself can become a source of pollutant, source of contamination that can spread through the ventilation system inside the building. Using properly control strategy that is these properly strategies are referred to the VDI norms, for example, can reduce this risk. On the other hand, we want to like to keep the performance of the rendering unit over the time and adjust and act on the rendering unit in case of malfunctions, in case of damages, in case of underperformance conditions. So there are also importance of the control and the remote management system. So taking a look in a deeper detail about which are the important strategies that we have to take into consideration. The first one that we can mention is the demand control ventilation. Demand control ventilation means that we want to introduce the right amount of air inside the confined space according to some sensors that are able to measure the CO2, VOC, or PM 2.5 inside our confined space. So regulating the speed of the fan, regulating the damper is an important strategy, because in this way we are sure that we are introducing the right amount of air, of fresh air inside the confined space that is required by the number of people that is present inside that space. And so At the same time, we also save energy when because we introduce only the one it's needed and in the right amount. The second strategy that I would like to mention is that we wanted to include some strategies like pre-post ventilation or night purging. With these strategies, we are able to increase the ventilation just before or just after the building is in use by the people, by the workers, the employers that are present, for example, inside the office. So starting the ventilation just before the entry of the people and closing just after can prevent that inside the building the level of some contaminants can rise and can prepare this environment for become comfortable and healthier and safer for the employee or workers or people that stay inside it. Also, night purging ventilation is an interesting feature, interesting strategy, because we can clean the air during the night when the building is often not used, and can prepare the air properly for the day after, in which the building is in use by the people. The third interesting strategy is guarantee pressure difference. This is important because guarantee a difference of pressure between closest environment can prevent the infiltration of contaminated air inside the building. So in that way, we are sure that inside the room we can control the quality of the air. That strategy can be implemented properly with the control of a variable speed fan that can keep the R&D unit in a different way. We can control the amount of air that we're introducing, and we can control also the amount of air that we can extract in order to guarantee a right difference of pressure. Another interesting thing is the fan humidity control. It's well known that humidity level inside the room is an important parameter in order to reduce the spread of viruses and bacteria. And control properly the humidity level and guarantee that this relative humidity inside the building is in the right range from 30 to 60%, for example, is the target for this control. But it's important not only to control properly the humidifier, but also to control that humidifier can become a source of proliferation of bacteria or contamination, avoiding the condensation inside the humidification chamber. So having a control on the supply air with the limit probe can adjust this level in order to prevent this particular risk. Another interesting feature is the control of the filtration. The level of filtration is rising inside the R&D units, and in particular the introduction of HEPA filter, the absolute filter with a high level of retention of contaminants. The control with a pressure transmitter guarantee the capability to check the status of the clogging of the filter, and in certain cases we can make some preventive maintenance on the unit, deciding to make the replacement of the filter when it's clogged, or we can make our action just before it starts to become really clogged, and so become a problem for the R&D units. Last but not least is also the importance of the introduction of sanification system inside the R&D unit. We read a lot about this kind of system that can prevent, that can deactivate the viruses and bacteria, the bacteriological contaminants inside the ventilation system. So many R&D units started to become equipped with this kind of system. So it's important that the controller is able to interact with them, to control them in order to make them work properly. So it is another important thing, an important strategy that we have to keep in our mind when we design the control system. Other interesting thing that, in particular, this is a peculiarity of CAREL products, and is considering also the VDI as a reference for us in terms of strategy, also implementing strategy for operation and maintenance of the R&D unit. So including some control strategies that are in line compliance with the VDI, guarantee that our R&D unit is able to reach that targets in terms of safety that are that are requirements given by these particular norms. As we talk in the first slide, also remote management system has a big importance, because with remote control technologies, we can continuously monitoring the condition of our system. We can interact with the unit. We can take immediate actions on the unit, like, for example, during the emergency or during malfunctioning of the units. So keeping the unit completely remote over time give the possibility to keep performance of the units over time and make us aware that our units are working properly and in a safety way.
Thank you. Sorry to interrupt you. A lot of things, but a lot of things because there are a lot of things that a controller can do, and it's really impressive. So let me try to focus a little bit on one component in particular, which is very important inside the handling unit, so the heat exchanger. So I will involve Paolo on the discussion now. Before starting, I would like to involve even our guest of today with another little poll. I promise it's the last one. Is a little poll trying to collect opinion related to the most important thing that we have to consider when talking about heat exchanger for heat recovery. So the question is very, very simple. It's multiple choices. So what are the most important characteristics that should be fulfilled to have a risk-free heat recovery? So let our guest answering, and then we'll take this result as a starting point to discuss about heat exchanger for a handling unit. So a few seconds again for the answers are arriving. 5 seconds again. 4, 3, 2, 1. We can close the poll.
Close the poll.
Just a few seconds again for the latest. Okay. Let's end the poll and share the result. So we can see that no cross-contamination and easy cleanable and disinfectable surface are the two most important things that we have to keep in mind. So I will take this result as starting point for Paolo for explaining us what are exactly the things that we have to consider when choosing and using a heat exchanger.
Thanks, Simone. Yes, as already anticipated by my two colleagues about this moment, is to increase as much as possible the fresh air that translates in increase of the energy consumption. This energy consumption could be controlled, reduced with the right use of the heat recovery system, with the heat exchanger that should be used in a safe way. Let's see now, going through this type of technology, which are like which is the right approach to use the heat exchanger in the correct way. We are going to start with one of the main families, that is the plate heat exchanger. Just a few words about the plate heat exchanger characteristic. A plate heat exchanger is a static component, a heat recovery component that is composed by different plates that are combined together, that creates gaps where the air can pass through and can release the heat to the opposite airflow. In the way we have heat exchange without any type of cross-contamination. We can have different sizes. We can use like plate heat exchanger for hundreds of meters cubic per hour, even till like hundreds of thousands of meters cubic per hour, with efficiency that it's possible to have like 60% up to 80–90%, keeping really low the pressure drop. the main characteristic is the geometry of the plate, the turbulence of the air to keep high the efficiency and keeping low the pressure drop. Just a few words about the terminology, because it's important to understand what is the differential pressure to know how to manage the leakage. The differential pressure is different from the pressure drop because the pressure drop is the loss of energy of the airflow that passes through the heat exchanger, while the differential pressure instead is a difference in terms of pressure between two different airflows. We have also a video, and this differential pressure mainly influences the pressure drop itself because it modifies the size of the gaps, because it's like a strength that is pushing the plate. This is important because in the, let's say, in hygienic application, mainly in hospital application, we can have really high velocity and also a great difference between two different ambient. That means that we need heat exchanger that is able to face this high differential pressure, because if it is too high, then we can have also elastic deformation can become also.
Sorry, Paolo, if the video was not clear for people, it was the space between the thin enlarged a little bit because of the pressure of the air. So the elastic movement of the air. Just because probably the video was not so clear.
Yes, exactly. That video wanted to show the deformation of the plates due to the differential pressure. This was something like has been accelerated. It was something to explain that the differential pressure has a role inside the functioning of the heat exchanger. But and we were saying that also in the application like hospital application and like a hygienic application, we can have high velocity, high differential pressure. That means that the heat exchanger should like support this high differential pressure. In some cases, with the right options, we can have heat exchanger that is able to resist up to 3000 Pascal. But to go back to the poll before, like the main characteristics should be fulfilled. One, the main answer was like cross-contamination. Well, cross-contamination is not like, let's say also the leakage, but we can, with the right differential pressure, we can give a direction of the leakage. And if the direction of the leakage goes from like supply to the exhaust, then we don't have cross-contamination. So it's really important to understand how to direct the leakage to avoid any type of cross-contamination. But in the case of the plate heat exchanger, as it is built, because it's are plates that are joined together, then we can have anyway a leakage that could be really, really low. That means that we can have a leakage that is lower than 0.5% of nominal airflow. In the graph, in fact, we can see different like heat exchanger with different type of sealing that can reach even almost 0% of leakage rate. That is a really low value. That means that in this case, we don't have to take care so much about differential pressure, because the leakage is always so low that we don't have never the cross-contamination. Another point is the proliferation of bacteria and fungi on not metallic material. In this case, in the heat exchanger, in our heat exchanger, we use like a sealing to cover the gaps of the corner profile. As you can see, that is able to face the proliferation of bacteria that is tested in a certified laboratory, and in the way we can assure the use of heat exchanger also in a hygienic application, because the sealant that is used is not like a place where the bacteria and fungi can proliferate. In addition, is also, of course, silicone free. Another main point is the resistance to the corrosion. In the poll, it wasn't like the best answer, but it's also important because in the way we avoid the corrosion, going to cover the casing that is made of galvanized steel with epoxy protection. The epoxy protection that is the one that we use, not toxic, not porous, and it is easy to cleanable because it's smooth. In the way, it's also no place of bacteria proliferation. So in the way, we like fulfill the characteristic should be cleaned, but also the characteristic to avoid the corrosion in any way. All these characteristics are defined and combined together by a conformity certificate that is delivered by a third-party laboratory that explains that the heat exchanger is suitable for hygienic application. So we have seen the cross-contamination that is really almost zero in the plate heat exchanger. We've seen the easy cleanable of the surfaces, and also that the not metallic material are not site of bacterial proliferation, fungi and viruses. Now let's go through the other type of heat exchanger, heat recovery system. That is the rotary heat exchanger. The rotary heat exchanger has the main target of the plate heat exchanger, but in this way we don't have a static component, but is a composite of a rotor that is moving, made of an honeycomb, let's say like an honeycomb matrix material that is rotating between two different airflows that are different from temperature and humidity, and it is able to absorb the heat from one airflow and release it during the rotation to the opposite airflow. Of course, the rotor is moved by a motor and is inside a casing. The honeycomb structure is really permeable to the air to increase as much as possible the efficiency and to keeping down, of course, the pressure drop. But since this is a component that is moving, we have to cover the gaps that are created between the rotor and the casing with some gaskets, something that can block any type of leakage. Let's go a little bit more about this topic again, the leakage inside the rotary heat exchanger. In this slide, we can see two different types of leakage: external leakage, internal leakage. The external leakage is something that belongs more to the unit, is the air that passes through the sides of the rotary heat exchanger. Now we should focus to the internal leakage. The internal leakage that can be influenced by the pressure driven, so the differential pressure that we've seen before. If you remember, we've seen the plates, this is like the difference in terms of pressure between the two airflows, and also a new one that is the co-rotation, called also carryover. The first one is also influenced by the fan position. We can control it with the fan position, and the other one can be controlled with the purging sector. Let's now go and focus a little bit more on the last, carryover and purging sector. The carryover is the phenomenon of transferring of particles of the exhaust air to the supply air. So this is a problem of contamination, the carryover, because some part of the air, the exhaust air, can be trapped inside the rotor that rotating is transporting these particles to the supply side. But we can control, we can avoid this type of contamination using the purging sector. The purging sector is a panel, as you can see, is the yellow panel that uses part of the supply air to clean the first channel, the channels at the beginning of the supply side. In the way, then we have a complete clean matrix that is rotating inside the supply side, avoiding any type of contamination. To have a purging sector that is working, should be installed properly. That means that it should be at the outlet of the supplier side, and also should be opened in the same direction of the rotation. This should be also well designed, because it belongs to the revolution per minute of the rotor, and also on the velocity of the front of the supply air. In addition, to work properly, it is needed to have the supply side in overpressure. The supply side in overpressure is also really important to avoid that the leakage that we can have with the rotary heat exchanger is transformed in contamination. We have here 3 out of 4 configurations that are good, where we can direct, as we've seen before with the pressure difference, we can direct the leakage from the supply to the exhaust. In that way, we can avoid any type of cross-contamination. It's important to understand the difference between leakage and contamination. And with a correct fan position, we can direct the leakage, avoiding any type of cross-contamination. And the fan position in, let's say, the not recommended one is where we have the fan on the building side. In the way we have the supply side in under pressure. That is not good because the leakage in the way is going to the supply side. That means cross-contamination. So what we suggest is to have the fans or in the outdoor side, or the fans that are between the heat exchanger as the two pictures above. This is like we have seen the, let's say, mainly the theory, but making the test, what are the numbers that we're talking about? If we have seen, if we have like the supply side overpressure of 250 Pascal, the circle green on the left. We have the purging sector that is properly installed and also well designed. Then we can have EATR, that means exhaust air transfer ratio, that is a contamination, that is equal to 0. 0 is the same number of the plate heat exchanger. If you look above also, you can see that also the ATR could be a little bit higher with a lower pressure drop, pressure difference, but even really low value. So this is really, really important.
0 is a very impressive number.
Yeah,
and
0.00 then.
I would say thank you for, because you gave two important practical suggestions, purge and pressure control. So I would say that considering all the discussion we experienced in the past months related to rotative heat exchanger, I think this is a very important point. So I will ask you to better summarize even for everyone.
I was too long.
What are the most important things that we have to keep in mind when talking about rotative exchanger?
Okay. Yes, this is a really good point. Let's like focus on 4 main pillars. The first one is the position of the fan. We have seen we have to look at the supply side that should be in overpressure. The second one is to have the purging sector well installed and well designed in the way we avoid the carryover. Then we need a correct installation, of course, and because the rendering manufacturer should know exactly how to install the rotary heat exchanger, knowing the purging sector. And then also the last one, that is the maintenance. The maintenance is really important to keep the rotary heat exchanger that is running in a proper way. It's also following these 4 pillars, it is not needed at all to switch off the rotor. Actually, it's really important because it's been shown if we have these 4 pillars that are fulfilled, let's say, there is no evidence that we can have a transfer of virus-landed particles that higher than 0.2 microns. And also we've seen that the leakage does not depend on the velocity of the revolution per minute. So if we stop the wheel, then we just stop the carryover that can be avoided, we've seen with the purging sector. In addition, if we switch off the rotor, we can have an increase of the energy consumption, and we can we can have like a discomfort inside that can increase, like also the spreading of the, we hope no, but of the virus. So it's really important to follow that 4 pillar and don't be afraid to use the rotary heat exchanger, because with that like 4 milestones we can use the rotary heat exchanger in a proper safe way. In our history, we have delivered heat exchangers in many hospitals, many like hygienic application, but I would like to focus on one. We have like Italy, England, and also Spain. One that is the hospital of Pordenone, where I think CAREL has supplied many of humidifier inside this
a lot of
application.
In this hospital we have supplied many humidifiers. So talking about humidifiers, I will then ask Andrea to explain us why a proper humidification system is important to maintain an hygienic a good hygienic level inside the air handling unit.
Yeah, for sure, humidification is one of the most important parameters that we have to guarantee inside the confined space for a critical application like hospitals, but not only for critical application, also for commercial one.
Yeah. As the first poll confirmed as well.
Yeah. So in order to design and to define the right requirements for the humidification, we have to come back to the norms, the regulation that give all the details refer in order to choose the right humidifier for the hygienic and safety application. VDI norms give requirements in terms of material because our humidifiers, and CAREL is a leader for the production of humidifiers, and as devices and equipments that are built with this characteristic. The humidifier for the hygienic application has to be made by the resistant material, resistant to the corrosion, easy cleanable, and with the material that not promote the formation of microorganisms. Like, so the typical material that we can use are stainless steel, for example, or aluminium. VDI 6022 give you also requirement about the drainage of not evaporated water. We know that when we make adiabatic humidification, for example, we need drop eliminators in order to prevent that not evaporated water can pass through the R&D unit and goes into the ventilation system and doesn't condensate in other part of the R&D units. And also give suggestion to create a properly drained pan to drain the water that we collect, we retain through the droplet eliminators. VDI also give some regulation, some restriction and suggestion in order in terms of controls, because it requires to have a limit probe. It's a mandatory features, and our humidifier, our control system are designed for using this kind of devices. And also give some suggestion in terms of using the water, because the type of water that we have to use, because it suggests to use demineralized water, drinkable water, but demineralized, especially for the adiabatics, because it improves the safety and hygienic condition inside the R&D unit. Another important thing is that humidifier, traditional humidifier with the recirculation or wet pad, are implicitly discouraged by the norm. So the norm suggests to use a humidification system that are able to introduce or steam, that is hygienically safe, or fresh water, but not the one that uses recirculation or wet pads. So which are the technology that can we use in order to fulfill these requirements given by the VDI? Isothermal technology are the most traditional one, because with the isothermal humidifier, we introduce directly steam in the supply air, in the airflow. Steam is safe by definition, because steam is aseptic. So steam humidifier are often mandatory for some critical application like operating theaters. And it requires minimum maintenance if they are used with demineralized water. We have different kind of humidification system. We have a humidification system, steam humidification system with heating elements or gas burner, all immersed electrodes. And all this kind of technology can be used in the hygienic application. But steam humidifier, as on the other hand, requires by thermodynamics a certain energy consumption. So, and alternative technologies can be the adiabatic technology. Using pressurized water humidifiers, we can reach the hygienic targets for R&D units if these adiabatic technologies are equipped with this feature that are the automatic washing and draining cycle for the distribution systems. All the components has to be provided in material like stainless steel, and using the mineralized water, we can guarantee a high reliability of the system. With all these characteristics, we can get, as for example, in the same way of the heat exchanger, we can get from a third-party certification authorities, we can get an hygienic certification, and we have some system that is equipped with this hygienic certification that can guarantee the reliability of this system that can keep hygienic R&D units. On the other hand, the other important thing is that adiabatic technology has a low energy consumption. So it's an interesting point that we have to take into consideration, because as Paolo had already mentioned, the amount of fresh air that we have to introduce inside the buildings is increasing due to the requirements given by the COVID norm and so on. So increasing the amount of fresh air during the winter time means that we have to increase the humidification load. So the requirement in terms of energy consumption had to be reduced if we want to be energy efficient. So hygienic, adiabatic humidification can be at the same time hygienic and efficient.
Oh, this point on reducing the energy consumption is very important, because since the beginning of this roundtable, we discussed a lot about health and safety around our components, but of course, reducing energy consumption is another fundamentally very important point. So I would like to raise a little bit of discussion around the solutions to even increase the efficiency and reduce the energy consumption of the rendering unit.
Yeah, one of the solutions that we would like to promote is the indirect evaporative cooling technologies. We already explained that adiabatic humidifier can be used in order to regulate the level of humidity on the supply side, but on the same time we can use the same pressurized water atomizer that we use for humidification, even also for the for controlling the temperature on the extract air without affecting the humidity on the supply side. This technology is called indirect evaporative cooling. So it works with using a water spray humidifier, place it on the extract side of an ND unit that increase the level of the humidity to the saturation, but reduce on the same time, using the adiabatic cooling effect that we have with adiabatic humidifier, reduce the temperature. So this technology is can get more efficiency of the R&D unit itself, and it is promoted by the norm and regulation, because we can see what is referred to the norm 13053 that promote the use of indirect evaporative cooling together with the cross-plate heat exchanger. But what I would like to say, one of the interesting points that we have, that we get from the synergy between CAREL, humidification, and Recuperator is the importance of the integration between the two components together. And probably Paolo can give us more advices regarding which is the increasing effect in terms of increasing cooling effect that we can get by the combination between an adiabatic humidifier, pressurized water humidifier, with a cross-plate heat exchanger made in the proper way.
Well said, Andrea, because we have seen the keys are the integration between humidifier, so CAREL, and heat exchanger, so Recuperator, and the other important key is to wet as much as possible the heat exchanger. We can see now an example that support what we have just like stated. We have three different combination of humidification system and plate heat exchanger. We have the first one on the left that is like a wet pad with a plate heat exchanger. So we humidify the air at the inlet of the heat exchanger, and then the heat exchanger is dry. Then we exchange the heat between the two airflows. The second case instead is with the humidification system that replaces the wet pad with the pressurized system that is going to spray, so humidify the air at the inlet and also inside the heat exchanger. So the heat exchanger has to be wetted. But we can do something more. If we replace the heat exchanger with a standard epoxy protection with a special coating like hydrophilic absorption coating, we can increase the wettability. So the second key that I've said before, the wettability of the plate to enhance the cooling capacity of the whole system. In fact, with the first example, we reach like 5.2 degrees of difference in terms of pressure temperature between inlet and outlet of the supply air. In the second case, if we replace the wet pad with the pressurized system, we can have a 20% of increase of cooling capacity, and we can go even more thanks to the blue coating, that is this hydrophilic absorption coating, that increases the cooling capacity even more, up to 35% compared to the first solution. So let's say again, pressurized system, humidification at the inlet, and the plate exchanger that should be completely wet. This coating, of course, can be applied for the whole range of products of Recuperator, of all like heat exchanger set by in the Recuperator portfolio. Now let's focus a little bit more on this coating. This coating is special because we've seen that it's hydrophilic and also absorption. It's able to retain the water on the surface. Then we can increase the wettability. We can create an even film of water on the whole surface, decreasing the whole temperature of the system. In the way we increase the cooling capacity. In this picture we have we show the wettability in terms of sigma of the plate. With the gold, we have a wettability of a value that is half of the wettability of the blue. Because like of the characteristics of hydrophilic and absorption characteristics. But let's see something like practical. We have two videos that can for sure explain better than me what does it mean hydrophilic absorption. The first video is with the epoxy protection. As you can see, we spray water on the epoxy protection, we have droplets, we have still droplets, we don't have like even film of water on the surface. And so we have
the drops on the surface.
Exactly, yes. It's not absorbing, it's just keeping, we have small droplets around the surface. If you see the second video, and like you wait 5 seconds because it's a little bit longer, and you can see when we spray water on the surface, we create an even film of water. It's impossible to see the droplets on the surface because it's just a film of water. Thanks to this film of water, we can have an increase of cooling capacity that we have seen before with the example that is 10%, 15% more of the standard gold protection. This is really important because in the way we can increase without increasing the pressure drop, is just using a type of coating, we can increase the cooling capacity. With the pressurized system, we have replaced the wet pad that has always a pressure drop. Then where we have a really efficient way. That's why in the standard, also in 3803 and in the 13053, it is suggested to use this type of technology because you can have really high cooling capacity just with the pressurized system and with the coating, the blue coating. And now we can see just the increase of performance thanks to the blue coatings, the blue dots, compared to the epoxy dots, that is the gold epoxy protection that is hydrophobic. And on the right, just picture that, like, say again, explain the formation of the film on the plate. On the left, we can see that the droplet completely disappear on the surface. This is the blue hydrophilic absorption coating. On the right, instead, we can see the hydrophobic epoxy protection where the droplets doesn't disappear, still remain droplet, as we can see, we have seen on the video.
These images are very clear and are showing a remarkable differences between these two things. So thank you so these are very important differences coming from different surface treatment, but at the same time, it's important to select the right configuration of, let me say, the combination of humidifier and heat exchanger for the indirect evaporative cooling. So, can you add some more suggestion of choosing the right configurations of the system?
We have focused up till now to the heat exchanger, but of course the system is a composition of
two things.
Exactly, of humidification system and the plated exchanger. Of course, it's really important, as we have seen, to wet as much as possible the heat exchanger. To wet the heat exchanger that works also like a water drop separator, because we have seen before that the geometries should be able to turbulence the air. Then it's important to exploit the gravity to wet as much as possible the plate. In the way we increase more and more the cooling capacity. On the left, we have like a picture that show you the behavior of the performance of different configuration. The main three are like top, side, and bottom, where the top configuration is where we exploit the gravity completely. Then we can have like a really high cooling capacity. But if we move the humidification system to the side and then to the bottom, we are decreasing the cooling capacity because we are wetting less the surface. So it's really important to spray water inside and to wet the heat exchanger as much as possible. But let's think something more, a little bit more complicated. We have seen just one plate heat exchanger, but we can work also with a multiple like combination of heat exchanger and humidification system. In the way we can play with one humidification system and two heat exchangers, also to have a control on the direction of the airflows. But it's always very important to keep in mind that we should like exploit the gravity, we should wet as much as possible the plate of the heat exchanger thanks to the pressurized system. Over the years, we have studied really a lot with the University of Milan, with the Polytechnic. We have like tested several configurations. We have tested several humidification systems with different types of pressure, and everything is inside our selection software that can give you an answer about the performance of the whole system, humidification plus heat exchanger, with the right amount of water to have a certain target of like cooling capacity. We have also published many articles that you can see inside our inside the net, many articles about the studies, about the model, and the results that I've already shown you.
Let me go back at the beginning of the presentation when we launched the poll. So many of our guests highlighted the importance of avoiding say the cross leakage in the plate exchanger. Another important thing was avoiding corrosion to maintain a right level of reliability. So can you explain us better what are the key aspects that we have to keep in mind in order to be sure even on this side?
Yes, because until now we have focused mainly on the cooling capacity, how to enhance the cooling capacity. But two main points are really important. One is the corrosion that we have seen before. It's important also for hygienic application, but even in this case where you're using water, it's important to have aluminum protected by a solution that is able to face the corrosion for different types of water types. And in this case, also this hydrophilic absorption coating has been seen that is able to face much better than the epoxy standard protection, because it's composite by two different layers. One is the primer, the other one is the active layer, the hydrophilic, that both of them are able to face the corrosion, to resist different types of water. And we can reach a plus 50% of resistance to the corrosion, higher than the standard epoxy protection. This is proved by different tests we've done in salt spray chamber, reaching the value of 1,500 hours in the neutral spray chamber and in acetic spray chamber with 300 hours. This is really impressive result. These are just the results of the test. As you can see, one edge of the sample is not covered by the tape, so the corrosion could be started from that point, but it happened because thanks to the right addition of the primer with aluminum. Another important point is the tightness. The tightness that we've seen before is to avoid any type of cross-contamination, but it's also needed to avoid any type of leakage of water in this case. We can test the plate heat exchanger to avoid any type of leakage thanks to a tunnel that we have implemented, where we can test the tightness in terms of water of the heat exchanger with a pressurized system. You can see this is a channel, we have fan, we put in under pressure the heat exchanger, we shower the heat exchanger really a lot, let's say 1000 liters per hour, and then we check if there are leakages. And we ship the unit only if the unit is completely tight. Most of the cases, let's say 99.5% is always tight. We deliver also, we supply a certificate that guarantee this tightness. In addition, when we have bigger unit composite by different modules, we are going to test it to guarantee to our clients also the tightness of the junction of the heat exchanger with composite with multiple units.
Okay, very. So we started the presentation talking about controls, managing air handling unit. We are ending now talking about how humidification are working together with heat exchanger. So the question back to Andrea at this point is how the control returns back on the stage to control even this part of the air handling unit as well.
Yeah, control as can have an important role in putting together all this part and grants a bigger value from the integration of all these components. So starting from the humidification system, starting from the evaporative cooling system, then going through the heat exchanger. So putting together all these components inside our units means that we have to make them work properly in order to minimize the energy consumption of the unit. And apply a regulation with a cascade control strategies that is able to control the different devices that compose the running unit and activate these different devices according to the minimum energy consumption that they require in for reaching the set point that we want to get with the R&D unit, means that we can control all these different devices, get the maximum value because we minimize the energy consumption using a cascade control of this complete system. This is a saving, a benefit that we can get in terms of energy consumption, but we also would like to get additional benefits from the integration between the controller, the humidification system, and the heat recovery system. And also we would like to preserve water during the indirect evaporative cooling. And in this sense, we are able to control the indirect evaporative cooling system and controlling the humidity on the exhaust air. And this means that we can get the maximum, the maximum effect possible in terms of indirect evaporative cooling, because in case we are closing to the saturation point on the exhaust air, we can reduce the power of indirect evaporative cooling because we cannot get more efficiency than the one we are getting in that moment. So this kind of control strategies put together permits to save energy, but at the same time also save water in this particular kind of application.
Good, thank you, Andrea. Very clear. Let me first of all, before jumping into the question and answer session at the end of this roundtable, let me thank our guests for the very clear presentations. And as we have seen, CAREL and Recuperator inside CAREL is able to offer a complete portfolio of solutions around the handling unit. So it's impressive how we can address these problems with an integrated solution. And let me sorry, I had some interaction with the technical direction here. Let me remember you the other appointments for tomorrow. It's I would recommend to not miss the other roundtable at 11:30 tomorrow morning, talking about humidification is set. So a more in-depth discussion of many of the things that we have seen today here. So before closing the roundtable, I think we can take a little bit of time to answer some questions that have arrived during the presentation. So we have a lot of questions on heat exchanger. That is a very hot topic. So let me raise the first one. Is during the presentation there was some images showing that the atomizer water was going in the opposite direction. So someone is asking, there is a particular reason for that or not?
Yeah, this is the first, let's say, the first result of our test made in the Polytechnico laboratory. We started to analyze the behavior that we have with the humidification system and the heat exchanger. It was just the beginning. We started to analyze also to orient the rack of the humidification system with the configuration of 45 degrees. From that point, we started to see that if we put the nozzles in counterflow, always say the inlet of the heat exchanger to the airflow, then we can increase the cooling capacity. Because in the way we are enhancing the distance of, let's say, the humidification inlet, humidification of the air, the inlet of the heat exchanger, and also we are opening the nozzle of the cone of the nozzles and having a more even distribution of the water over the plate. This is working like more or less also like a chill booster. Is to increase as much as possible the fog of water that we have at the inlet of the heat exchanger. So that's because of the first results that we got with the University of Milan.
Let me take another one. This is very practical question. So how can we calculate the right amount of water necessary for indirect evaporative cooling?
Yes, always on this topic we have done several tests with the University of Milan, with the laboratory, said before, like with different configuration, and everything has been like implemented inside the black box that we have insert inside our design software, Rex selection software. In the way you can select the right heat exchanger following also your dry conditions, and you can add like humidification system, calculating the right amount of water, analyzing the excess of water, the temperature that you get, or otherwise you can have also a set point, and then the software is able to calculate for you the right amount of water needed for your unit.
Another last one for Recuperators, then we will return back even to Andrea. Another interesting question is, what is the typically durability of the blue coating and how it changes with installation sites? If it's installed, they're asking on coastal area, urban, industrial, how this affected the durability of the coating?
We have done test about the durability in salt spray chamber. We have seen the durability compared to the standard epoxy protection is higher, so it's a 50% higher. Then, of course, it depends on the type of water that you're using, when you spray water, on the type of air that you're treating. But we've seen that for standard application is much better than the standard epoxy protection. Now, many of the blue heat exchanger are already implemented inside the data center, because this data center is the main application that is pushing so much, because in that application you can have really like use and saving of energy of this type of technology, thanks to the free cooling hours that you can implement in that type of system. And we are like selling BeBlue since like 4 or 5 years, and without any problem, in different size, in size and on different sites also.
Okay, thank you. I will return back a little bit on Andrea with a question on humidity level. Relative humidity is a very important parameter to control in order to have the right condition of the air. So why is so important, the humidity control?
Yeah, the humidity level is one of the parameters that affect the comfort and inside the room. Guarantee a humidity level in the range between 40 to 60 is recommended by all the norms related to the HVAC system. So it's well known that the effect of humidity level in comfort. But the studies that are developing during this period, this particular period that in which we are affected by this virus, is the spread of the COVID-19, increase the evidence that also humidity has an effect in reducing the spread of viruses and bacteria inside confined space. So it's another interesting point to which we have to promote the introduction of the humidification system in our ventilation system. So probably tomorrow our colleagues probably we go in deeper in detail in all this part related to humidification system. Sure. And so I suggest the people that are the audience that we have now to stay tuned and to follow us in for the
so
next,
we book our agenda for tomorrow morning at 11:30. Another question of BeBlue. BeBlue is very popular. The question is if we can apply BeBlue on steel plates as well.
Let's say the BeBlue is something that is a coating. As a coating can be applied to all surfaces. In our catalog we have aluminum plate heat exchangers, and so it can be applied to aluminum plate heat exchangers, but of course it can be applied also on other material. We have to understand if the primer can be used on that type of support. But let's say the BeBlue is always a coating, so as a coating can be applied on different surfaces.
Probably one of the last questions, because we are running out of time. From the audience, there is a very strong question. Probably you have seen that during the Andrea presentation, we have shown our CAREL, one of the most, let me say, popular controller for air handling units. So someone is interested in CAREL, and he is asking how is the experience and.
Yeah, so let me spend just few words about the CAREL. CAREL is a quite brand new product that we are introducing in the market just in the last year, in which we would like to include all our knowledge regarding the control of R&D unit, but not only the control of R&D unit, but also to specify a lot of control strategies. The most are explained during this presentation, related to keeping the right indoor air quality, to keeping the right hygienic condition. And we get some experience on the field. We get some case studies. We are the most are here in Italy, because it's easier for us to work better in Italy, but also we have some abroad. And yeah, it's a good product, very nice, even because it's explore a lot of the potential of the connectivity, because it's equipped with the web server pages already, and is plug and play for the connectivity with our cloud service, our remote services, Astera. So it's easy to put on the field and then get it connected wherever you are, and get it controlled wherever you are through the potential of the connectivity. So okay. I think that is a good product for promote this kind of control strategies, to promote hygienic R&D unit for the OEMs and also for the installers and contractors.
Okay. So of course, if the people attending is more interested in some details about the product, should feel free to contact you. Probably the contacts are in the platform of Chillventa. So there is one last question arriving by an anonymous attendee. Who is better, Juventus or Milan? This I can keep for myself. I say Milan. Okay.
Because you are moderator, we cannot say something like that.
So I think we run out. They are confirming live now that Milan is so I'm
the right
the same. I don't know if it's the same or another, because this anonymous participant is confirming Milan. Okay, so we'll say that we run out of time, so it's time to close the roundtable. So thank you very much for being part of this event. Unfortunately, only virtually, not live. I hope that very soon we'll be able to get in touch in person again. I recommend again tomorrow morning the session on health and humidity, and thank you again. Thank you to our guests.
Thanks, Andrea. Thanks, Simone.
Enjoy
Thanks,
Chillventa.
Special thanks from Paolo Liberati. Bye.
Bye-bye.